Scatter say about our energy level?
It's over 9,000!
Whoa, Ben. I'm really confused as to what just happened. Do you have any idea what's going on here? I really wish someone was here to explain all this to us.
Hey guys.
Oh my gosh.
What's going on?
Nothing really. We're just really confused as to what's going on here. I mean, we just like someone was just like jumping around in here, and I really don't know what's happening.
Oh, okay guys. What you just saw was an electron. It was jumping from energy level to energy level. Now, you may ask, what is an energy level?
What is it?
That's a really good question. We have proton, which is positively charged, and spinning around really quickly in position and relatively unknown momentums are the electrons. They don't make up the nucleus of the atom. They go around. Now, each electron has its own specific amount of energy, which means that it is in a certain energy level. So before we actually learn more about how much energy each of these individual electrons has, you should learn more about the energy levels. Okay, energy levels. There are 7 energy levels, 1 through 7. 1, 2, 3, 4, 5, 6, and 7. Well, the energy level corresponds to the amount of energy an electron has in the respective energy level. The greater the energy level, the greater the amount of energy there is. Bart, you should be in the
So
shot.
can an electron jump between energy levels?
Okay, yes. An electron can jump energy levels. As an electron jumps or goes down an energy level, it emits or absorbs a photon with the energy equal to the difference between the energy of the 2 energy levels. Now, a photon has to have exactly the amount of energy necessary to jump 1 or go down 1. It can't be in between energy levels.
Can you calculate the energy of an electron in a given energy level?
I'm not sure. Let's ask the electron.
Alright guys, Alright, we're gonna go find this electron, right?
yeah.
We're gonna do it?
Alright.
Team on 3. 1, 2, 3.
Team!
Alright, so you're an electron, right?
Yeah.
Wait, hold on. How fast were you going?
Yeah, that was a doozy.
Well, I would tell you, but now that you've caught me, I really can't.
Oh, freaking Heisenberg. Okay, question. Can you help us?
Yeah, I'm an electron.
So you can teach us about energy levels, right?
Of course.
That's great.
Alright, let's go do this.
I am a hydrogen electron, and hydrogen is the only element for which it is easy to find the energy level of an electron. And energy, E, for hydrogen is equal to E1 over n squared, where E1 is the ground state of the electron, and it is negative 13.6 electron volts. And n squared corresponds to the energy quantum number squared. And your energy quantum number goes from 1 to 7, depending on which level you're at. Here's a practice problem for you guys to work on.
To explain.
Okay, These are the energy levels of photons given off by an atom that behaves similar to hydrogen from the n=1 to the n=4 quantum state. Figure out the energy of the ground state.
So in order to solve this problem, we know that the difference between n=1 and n=4 has to be the greatest possible difference of the photon, or the greatest possible energy of the photon, correct? So this would be the 54 eV. So we know that E1 minus E4 has to be equal to 54 electron volts.
We also know that E sub n equals E1, the ground state, over n squared.
Right, and because of this, we can set this same equation up so that E sub 1 minus E sub 1 over 16, which is 4 squared, is equal to 54 eV. Now we can just go through and just solve this for E1. We get 15 over 16, E sub 1 is equal to 54 eV, which, and if we just cross multiply by 16/15, we get E sub 1 is equal to 57.6 electron volts.
However, since it's the ground state of a hydrogen atom, it has to be negative. So negative 57.6 eV is the final answer.
And that's everything that you need to know about electron energy levels.